Okay, so welcome back. Let's keep talking about bonds. So remember in the last lecture we talked about the number of electrons and how that determines the type of bond formation. So the electrons follow the octet rule. The maximum number of electrons in the first orbital will be 2. The maximum number of electrons in the second orbital will be 8. The maximum number of electrons in the third orbital will also be 8. So 2, 8, 8. Every element is trying to fill its outer shell. Now it doesn't matter necessarily if it's going to get rid of an electron to lose the outer shell to drop down to the next inner shell that is full, or if it grabs, gains, and adds electrons to its outer shell. The goal is filling the shell. Make sure the shell is full, whether it's the first shell with 2, the second shell with 8, or the third shell with 8. So we talked about ionic bonds in which one element will steal electrons, the other element will lose electrons. We also talked about covalent, in which elements will share their electrons. So in a nonpolar covalent, it's a 50-50 sharing. In a polar covalent, we get the slightly unequal, we'll call it 60-40. With nonpolar covalent, we have a single type of covalent bond in which one electron is shared from each. We have a double in which the elements share 2 electrons, and then we have a triple. Unfortunately, I don't have a picture of a triple, but nitrogen is our example of a triple covalent bond in which 3 electrons are shared between each of the nitrogens. So last thing to mention about bonds, the stronger the bond, the more energy that it stores. So when bonds rupture, energy gets released. So most of the food we'll talk about in the next chapter will be formed through single and double covalent bonds, sometimes triples. But lots and lots of covalent bonds create food. So when you eat the food and digest it, you're actually breaking those bonds, and that's releasing energy. What we do want to now look at is our third type of bond. And this is what's known as the hydrogen bond. The hydrogen bond forms in water, between water molecules. Now, the bond we're looking at right here, that bond, or that one there, or this one here, those are all covalent bonds. They're polar covalent bonds. That's the thing to remember about water. When it forms, the 2 hydrogens and the 1 oxygen set up a polar covalent bond, and that is what will hold that hydrogen to that oxygen, that hydrogen to that oxygen. But what is unique here is that because of it being polar covalent and that slightly unequal sharing, this sets up a very slight positive charge on each of the hydrogens and a slight negative charge on the oxygen. So that way, hydrogens still have a little bit of a positive charge that they're trying to balance out with another negative, and the oxygen has a negative charge, it's trying to balance out with another positive. So again, this is what sets up and creates the hydrogen bond. All right, so this bond is, the hydrogen bond is between the hydrogen of one water and the oxygen of a different water. Alright, so what we're looking at here, this is a hydrogen bond right there. That's another hydrogen bond. That one is another, and another, and another, etc. So all these little dashed lines represent hydrogen bonds. The hydrogen bond holds one water to a second water. Now internally, the bonds that are formed internally this bond here, that bond there, that one, so on and so forth. All of these little bonds, those are those nonpolar covalents. But the yellow highlights, those are hydrogen bonds. So because of this bond, this sets up what we call the properties of water. Water is essential to life. Every living thing on Earth needs water. As far as we know, all life anywhere, may exist on other planets, requires water, and it's adapted and evolved to these unique properties of water. Alright, so our first property of water is that water has the ability to absorb large amounts of heat, or we could say energy. That hydrogen bond can bring in a large amount of energy before water actually changes temperature, before it goes up a degree. In order to drop the temperature, though, you have to remove large amounts of heat or energy. Let's put that back up here. Heat / energy. In order for water to go down in temperature. So think about how this benefits you. On a hot summer day, your body temperature does not go up because the water in our body is able to absorb a lot of that environmental temperature, that heat. So it's 105 degrees outside, heat index, and you walk outside, your body temperature doesn't immediately go to 105. It balances out. It absorbs that heat very, very slowly before your internal body temperature would go up. On the negative, if you're running 102 degree fever, it's difficult to bring your body temperature down because it holds that heat, it retains that heat, it has that heat of the ability to hold that heat and that temperature. So when we look at water on the temperature spectrum, it has a massive range in which it can be in liquid because of that ability to hold that heat or that energy before it would actually change temperature. Eventually, though, it will change temperature, and if we reach a certain temperature point, then we change state. We go from solid to liquid to gas. Okay, so the second property to mention here. Water has a high heat of vaporization or evaporation. So it takes a lot of energy to reach this 100 degrees Celsius or 212 Fahrenheit before water goes from liquid into that vapor or that steam state. So if you guys are cooking, hey, I'm going to boil some noodles and make a pot of spaghetti, be careful. The steam coming off the top of the pot, that steam rolling up, is actually over 100 degrees Celsius. That's going to burn you worse than the water boiling on the stove, which is right at that 100 degree mark. Steam might be 110 or 120 degrees. So it has a higher amount of energy in it. But it takes a huge amount of energy and heat to get to that point, to go into that vaporization or evaporation state. Okay, so two key properties of water here that we want to remember and make sure we're comfortable with. Ability to absorb large amounts of heat or energy, and then this high heat of vaporization. Now, another important property of water is that water acts as a universal solvent. Okay, it's pretty much the basic liquid for nearly everything on the planet. You have a solution that is a liquid with stuff in it. Solvent is the water. So there's a glass of Coke or Pepsi for lunch. That's a solution. It has water, which is a solvent, and then a bunch of solutes put into it. sugar, carbonation, caffeine, phosphate, blah, 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 all the other stuff that's pumped into making a glass of Pepsi or a glass of Coke. All right, so water is this universal solvent. It's pretty much everywhere we look, everywhere we go. When we look at anything liquid, water is associated with it. And then different solutes are dissolved into this. This is going to be an important one to remember. Anybody heading towards healthcare, lock in on this one. This one is essential for healthcare. When you talk about IVs, prescriptions, medications, body solution concentrations, water is essential. Okay, so definitely an important one for us to remember. Other properties. Water is cohesion. The cohesion of water allows this insect to walk on top of it. So the cohesion of water means water sticks to itself. It sticks together. It's sticky. And that creates surface tension. That's what we're seeing here. This little water strider, this insect is standing on top of water and walking on the water because the cohesion of water allows it to create a surface. Now, obviously, we can't walk on water. No person can because we would break the cohesion of the water molecules. But that's what allows this insect to live. It has adapted and evolved to a lifestyle of walking on water. So if you think about a teardrop, a raindrop, etc., those formations are all due to the cohesion of water molecules sticking together. Another feature about water is this thing called adhesion. This allows it to move through the cardiovascular system. So water is going to move through the cardiovascular system, through a plant, through all sorts of different systems, because the water sticks to other stuff. So adhesion is the water sticking to other things. So to the side of a straw when you're taking a drink, to the blood vessels as it gets moved through the body. Now, sticking doesn't mean it's glued on and attached, but it enables it to move in a suction action or working with gravity. So you think about drinking through a straw. As you're creating pressure on that straw, the adhesion of water helps it literally move up the side of the straw. Okay, so these are all properties of water that make water important and essential for life. The last property to mention is that the frozen form is less dense than the liquid form. Okay? Ice floats. It's not a crazy concept. It's something that we take for granted. But that's essential. That is absolutely essential, that ice floats. Life is evolved to this. So whether it's ice cubes in your drink, or a polar ice cap, or an iceberg, this floats. This allows the water in the frozen form to sit above liquid water or on the surface. In the Midwest, in Illinois, you think about when we get our winter freeze, ice forms on the top of the lake, and then the water underneath stays insulated and liquid. That allows fish and turtles and frogs and all those aquatic animals that live in those ponds and lakes to survive throughout the winter. If the ice, when it froze, if it sunk, then all your little fish down here, everything that lives below the water, would not survive a winter, because the ice would freeze and go to the bottom, and then it would freeze from the bottom up. Okay, so an essential, absolutely critical component of water. Okay, and before I forget, I apologize I didn't do this earlier. Let me drop this in here. We've been talking about these learning outcomes. Number 4, right here. discuss the unique properties of water. So make sure you guys can discuss the unique properties of water. This is essential learning outcome for our course. That's actually number 4 in the course. Make sure you're comfortable with the properties of water.